Good morning, good afternoon, everyone. I'm Megan Matheson. I'm the co-lead of the Canadian Marine Shipping Risk Forum and the Director of Strategy Engagement for Clear Seas. This session will be recorded and the presentation will be posted on our website after this meeting, and everyone will be notified when the recording is available. Before we get started today, I'd like to take a moment to acknowledge that I'm joining from the traditional ancestral lands of the Snuneymuxw and Snuneymuxw First Nations on Vancouver Island and express my gratitude for their stewardship of these lands and waters since time immemorial. Further introductions. The Canadian Marine Shipping Risk Forum is a community of practice launched in 2019 with the support of MEOPAR, the Marine Environmental Observation Prediction and Response Network, and hosted by Clear Seas. The community of practice is open to all who are interested in the work of understanding and mitigating shipping risk. Thank you for joining today's webinar. It's part of a series that's focused on technology and its role in mitigating shipping risks. If you missed any of the previous sessions, I'll put the link in the chat and you can take a look at your leisure. So I'd like to ask everybody to remain muted for the presentation, but afterwards you are encouraged to raise your hand, unmute, come on camera, whatever you like, to ask questions and engage with our excellent presenters today. Or if you prefer, you're welcome to type your question into the chat function and I will ask the question on your behalf. So today we are focusing on the OneHarbour platform that is hosted by DataFax and in partnership with the Port of Halifax. And we have two presenters today. I'm calling it the Corey Show. We have Corey Kirkhouse, the Director of Business Development at DataFax, and we have Corey Gleason, the Deputy Harbour Master for the Port of Halifax. DataFax is a Canadian company that turns complex operational data into interactive environments where teams can see what's happening and act on it. DataFax's platform integrates enterprise systems, Internet of Things devices, and operational data into a single view. They are currently providing solutions to the Royal Canadian Navy, the Port of Halifax, and GE Transportation. And the Port of Halifax is a major ice-free natural harbor in Nova Scotia. It serves as a key Atlantic gateway for Canada, connecting to over 150 countries. It's a diverse port for both cargo and cruise ships capable of handling large vessels and is strategically located on the Great Silver Route. I will hand over to Corey and Corey to take us through their presentation today.
That sounds good. Thank you, Megan, and thank you for hosting us today. We're calling in both from Halifax here in a shipping container, which I think is fitting for the conversation today. I'm just about to share my screen, and Megan, if you give me a thumbs up, I can make sure it's coming through. Perfect. So excited to be presenting to everybody today, and we're going to be introducing DataFax, our platform, what we do, and we're also going to be speaking about Port Halifax and how we've configured a solution here. And I think over the past year, we've done a project where Port Halifax has gained feedback and understood Port Halifax's use cases to configure the platform specifically for the needs of the Operations Center. So Deputy Harbour Master Gleason here is going to give an overview of the Operations Center, and it's standing up that practice here in Halifax for 24/7 operations. We'll give a bit of an overview of DataFax's platform and the technology that's underpinning the solutions here. But what I think is going to be most interesting is actually a live demo of the OneHarbour solution with the real-time operating picture of Port Halifax. And from there, we'll do a bit of a back and forth just on how it's been implemented, some of the information and use cases that have arisen, and we'll wrap everything up with the lesson learned along the way, because we've had a successful configuration and test period, and we're continuing to work together. And there's quite a bit of interesting things under development, not just within Port Halifax, but more broadly speaking. And of course, we'll leave time for some Q&A here. So before I turn it over to my partner in crime here, Corey, I'll just give a bit of an overview on DataFax. And DataFax got its start with GE Transportation, and what we did was we took real-time operational data and combined it into a single pane of glass. And one thing that's been consistent about all of our configurations and implementations is the enthusiasm we get from the end user when they see their data within this interactive environment that they control. We took those lessons learned with terminal operations systems and applied them to the Royal Canadian Navy, where we're now going through the procurement and implementation for managing the dockyards on both coasts. And that's the activity of the vessels alongside, as well as the waterfront management. We've done a number of different configurations, not just for the real-time operations, but also for complex asset management of vessels within the naval context, and as well as mapping training curriculum and systems. And what this all comes together as is a way to map complex systems and interact with them, and then be able to control them all within a lightweight Chrome web browser environment. So with that, this past year, what we've done through Innovative Solutions Canada program and Transport Canada's Innovation Center is work with Port Halifax to understand the use case of the Operations Center, which we'll dive into in a moment here, and configure our platform, which is essentially a low-code environment on the back end where we're able to take data, create a scene, take the real-time data and map it within that scene, and then integrate the business processes and the controls for a particular use case or organization. And that's where it gets really interesting at how we're able to quickly tailor it for different organizations and implementations. So with that, I'm going to hand it over to Corey G to just discuss the Port Operations Center and what's happening here at Port Halifax.
Thank you, Corey K, the Corey K Show. So thanks very much, folks. Good morning, good afternoon. My name is Corey Gleason. I came to the Port of Halifax in 2023. Spent my last 38 years with the Royal Canadian Navy. First half of that as a communication specialist, and then later on as a naval warfare officer, and then finishing up my career as a part of the national shipbuilding strategy, bringing in Canada's Arctic and offshore patrol vessels and circumnavigating them around North America for the first time in upwards of 65 years. The Port of Halifax approached me with an interesting problem that I personally wasn't even aware of, that the port wasn't functioning and operating an operations center 24/7. We all know from a supply chain standpoint, safety, security, emergency management components, there's some real challenges to that, particularly when folks are going home at 5 o'clock at night and then ultimately regrouping at 2 o'clock in the morning to understand what the issues are. So I was brought on into the team to turn the port into 24/7 operations. And what you're looking at here is my phased approach that I presented to the Port of Halifax and how I was going to do that, identifying a whole host of different challenges that needed to be addressed, and then subsequently getting to a finish point where we were optimized 24/7. So when I arrived here, the port had a few UHF and VHF radios. They were just kicking off the start of a port information management system, but they didn't have any visual or real time awareness in the port. So I was desperate to find sources of means to actually implement some mapping that would really kind of map out the whole harbor, understand all the different activities that were going to the harbor that could contribute to real-time maritime domain awareness insofar as supply chain activities. And when you look at this thing, it really is a dual-use technology between military and industry. But notwithstanding that, I personally didn't have the vision to get DataFix here. They're the ones with the vision. I just contribute to trying to make it better and more suitable for the Port of Halifax. So we kicked things off with about 300 cameras in the harbor. Not much of any other sensors other than your standard weather sensors, the port management information system, and a whole host of different web pages that I would have to go to create an understanding of what would be going on in the port, and quite literally have to write everything down in a notebook to get an appreciation of each activity that was happening in different parts of the port. And we'll show you how we tackled what that looks like in future pictures. So the first step was opening up the operations center and hiring the staff to get them in there. And the second part was working with the PIER, which is our Port Innovation and Engagement Research Center right next door to the operations center, to start working with members to understand what it is, what kind of products that they're working on that we could bring into the operations center and integrate into our systems that would focus on improving supply chain efficiencies. And this is an amazing system that would afford us the opportunity to do that. But before getting there, I want to share this next page with you. That's a dashboard. This dashboard was, when I talked to you about those 20 different websites that I would have to go to and write it down in a book, essentially what we ended up doing was creating a dashboard where we could use Power BI tools and API tools and bring everything together in a single visual reference, just like similar to walking into an airport. When you see when you see the screens, it's very intuitive. You know exactly where you need to go. You know if there's any delays, and so we created this environment in the operations center. And this was really just phase one of our approaches. The next thing that we brought into the operations center was an item called EMSA that was developed by Transport Canada, or developed for Transport Canada. And it's an enhanced marine surveillance and awareness system, originally designed for communities on the West Coast to provide them some awareness in their harbors, or in and around their harbors, because generally speaking, shipping that's going up along the coastline of British Columbia, the first responders are going to be the communities closer to the waterfront. So they needed some sort of awareness. And so when I saw that product, we decided, I requested Transport Canada if we could get our hands on it, and then work with them to improve it a little bit more, to add some other features in it, like weather. Halifax, you may or may not know, is threatened annually by hurricanes. And so we created an environment in EMSA where we could actually track the trajectory of hurricanes, understand when it was going to make landfall, speed ships up to get in the harbor, speed ships up in the work while they're alongside, get them out of the harbor, and ultimately shut things down at a very specific time and know exactly when we could turn things back on again. So a lot of work was done in the background to get us to a place. But what you're looking at here on a screen is a whole host of different systems that are being presented in such a way that is still a little bit limiting. When we get to what DataFX can do, it'll give you a real appreciation of what the transition truly is from, you know, a flat screen with words on it and a couple of interactive buttons on the left-hand side and a list on the right-hand side, to one of your most sophisticated systems that are out there today.
Thank you for that, Corey. And then in working with Port Halifax, one of the things they invested in was a centralized data management and a great implementation with Databricks, which was a great foundation. And that's what was powering the dashboard and ultimately enabled the solution I'm going to show you here, OneHarbour. But what DataFX is really doing is transforming how people understand and interact with that complex data, so they can make faster and more clear decisions. And we had a good set of data to start in Halifax, but in the past, we've started with data no matter what format it's in, whether those activities are in a spreadsheet, which is often how things are scheduled. If you have 2D PDF schematics of the port infrastructure. In the case of vessels, we were looking at how enterprise databases were exporting defects and mapping them on PDFs. We take all of that and combine it into one single interactive platform. And that's what I'm going to show you here, which is a real-time view of the Halifax Harbour. So here we have Port Halifax with what's going on outside the window right now. So you can see we've started with setting our operational area, which has the Bedford Basin here and the 9 nautical miles out from the pilot station. And then we start to place information in that. So we've got the vessels moving around the harbor, of course, and we've got multiple sources for that. We've got the infrastructure alongside, which is something that's very interesting about how the game engine that underpins all of this allows for the visualization of different assets that goes beyond just the GIS map. So what you're seeing is real-time information, multiple sources, with the ability to apply the business processes to make it interactive and to make decisions easier. So a couple of the components that go into making this are one, the environmental data. So in the case of Port Halifax, we started with open source GIS information from the Nova Scotia Hydrographic Service. And if you were operating a port around the world, that's where we would start. So OpenStreetMaps is a great basis, but we're also able to add higher fidelity information. One of the things we're looking at now is bathymetric data from Keras. So we've tested and integrated the open source from Nona. But if there is a proprietary set of data, it's just as easy for us to get that high fidelity in here. But that's to say, it's very easy to get started with this venue with open source data. From there, the other information related to the environment is integrated, and that can come from a number of different sources. So, for example, there's the Smart Atlantic buoy here in the mouth of the harbor, and this is again helping us get some information on the environment from different sources. So we've got temperature, wind speed, and direction out there. We've got the tide information coming in from Environment Canada. We've got sensors on the bridges as well, looking at the current bridge height. So we're starting to create the venue with the context about what the current conditions are. And that's pretty simple to take that data and map it to different locations in here. Or I should say simple in terms of what we implement. Where it starts to get more interesting is, taking that data from text fields and lists and starting to visualize it. So one of the things we saw in the operations center early on was that the operations center coordinators would have two screens open. They would have the AIS data, so they could see the vessel location, and then they would have Windy open in a different application in order to see the fetch of a vessel on approach. And what we can do here is start to take multiple sources of information and start to cross-reference them. So I can see what the wind speed is from whatever my sensors are throughout the harbor, the wind direction from an open source API. Again, this can be something proprietary if you have winds already, or if you have currents, the game engine is able to render that information in the same way. So now what we have is more of a living, interactive environment, and that sets the stage for the venue. Where it starts to get more interesting is what the activity in the harbor actually is. And that's a good start for AIS. So that's, of course, the industry standard for tracking vessels in the harbor, but I think at Port Halifax, there's a unique relationship that's worth mentioning to the Canadian audience in particular here, because at the end of the day, DataFX does not generate data. We are taking the information that exists from the port, open source information, and combining it into a venue, an operating picture here, where we can increase the fidelity as we go. But I'll pass over to Corey to talk a bit about the AIS feed.
Yeah, okay. I think what I'd like to do is just start from the harbor entrance and work my way into the harbor. So Corey has indicated a little bit about some of the challenges that the Port of Halifax faces on a day-to-day basis, and we're experiencing that today, as a matter of fact. We have a low pressure system that's generating some energy to the south of us that will impact our operations into the evening this evening. And what the challenge today is the ships are getting bigger. And we recently had to upgrade the size of our tugs to facilitate bringing ships into the harbor, further out of the harbor, and to escort them in, made up with lines on them to safely bring them into the harbor. This is largely to avoid events like Baltimore. Certainly, we didn't have a crystal ball to predict an incident like that to ever occur, and a terrible thing to happen. But we were well on our way to mitigating that before the events actually occurred in Baltimore, which really kind of validated a lot of our work. So those sensors and that Corey spoke of are extremely important to us to have access to, and to be able to visualize contextually what the potential is for us to have to stop operations. And so the first part of looking at this is us being able to forecast using the sensors and tools in one place instead of a series of different screens, to be able to understand what's going to be happening in the next 96 hours, communicate that out to all the ships that are destined for the Port of Halifax, and determine whether or not we can speed them up or get them just to slow down and save on gas before they enter the harbor. The next step is, as we get closer into the harbor, just south of it, the Atlantic hub, where you see the 6-minute marker there, you'll see these lines on the system, and these kind of light blue lines are geofences. Those geofences are important. So the first geofence as you enter the harbor triggers a billing sequence in our port information management system. And then subsequently, as ships move through the harbor, these call points or geofences get triggered to generate awareness in our port management and information system, which just, if you were to look at it, is just really just a bunch of spreadsheets on a little bit more sophisticated system, but nowhere near as manages this. These circles that you're looking at are anchorage positions. So if a vessel goes into one of our anchor positions and decides to drop anchor and they're not in our port management system, it triggers an alert for the operator to investigate why there's a vessel in those anchorage positions. More importantly, where you see the geofences along the shoreline, those are actual security zones. The moment that DataFX turned this system on, we had a vessel that was in the middle of the Narrows there, right where his cursor is, that decided that it was going to proceed alongside our facilities without permissions to do so. Within seconds, when the system went on, there was a trigger that warned us that there was a vessel alongside there that shouldn't have been, and it wasn't in the port information management system. So that created a breach of security. Which told me that the system's immediately doing a lot of the things that we wanted it to do before it even kicked off. The next thing is the cranes. So when we think about cranes, we know that cranes are important factors to move cargo, but we don't think about them generally in scheduling and managing berths. And the awareness of the cranes and the operational capacity of the cranes is really important for a host of different reasons. First of all, if they're out of service and they're working on them, there could be lines and things like that that are hanging down from them. And so there will be no clearance for the vessel to proceed alongside because it would be dangerous. And so that's a first trigger from a safety component. The next component is supply chain and efficiency. If we know that we have 3 cranes operating and we have a vessel that's proceeding alongside and has 750 sea containers that's going to move, we know that a crane is going to function moving about 25 sea containers an hour. So we can do some simple math to understand how long that vessel is going to be alongside. But if during the 12-hour or 15-hour visit while they're moving the sea containers, that one of those cranes go down, this system can allow the operator and the operations center to understand that and understand how that follow-on effect, because they're still going to move those 750 sea containers. It's going to take them longer to do it. And that follow-on effect will impact all of our scheduling and all of our other movements. And we start jigging things around inside the harbor to reassigning assets to go work other vessels, because we know that berth will not be free as originally planned. The next thing is an interesting one that I personally didn't initially think of until we started developing this and bringing it into service was we have a lot of learning institutions who want to place a lot of different devices in the water for science and research. And with those devices come navigation warnings. And the navigation warnings are yet again another place where you have to look to source information to understand where these things are. But it's not it's a numbers and textual context. So you have to plot those things. What DataFX can do is it'll alert us, or at the very least, show us where there are little anomalies in the water that we plan to put in there, and it'll allow pilots, tugs, and the workers of the harbor to understand where these devices are, know that they're planned to be there, so they're not an anomaly that shouldn't be there, and avoid them. And so allow us as a harbor to work together to support research and technology, but at the same time keep the supply chain rolling. He talked a little bit about sensors, and sensors are truly important for a whole host of different reasons, and where we talked about why they're important at the mouth of the harbor, but really important on going underneath bridges. When we get some of these larger vessels, they have a high air gap, and that high air gap is extremely important. Anything above 46 meters, we're paying a lot of attention to. And there's 3 checks and balances that we were doing, and we continue to do those 3 checks and balances as this is in production. But this gives us a real true visual understanding of the bridge flexing, the bridge height when the vessels at different times of the day, and really kind of presents a kind of a picture for our pilots to build confidence as they're moving through the harbor, that they're moving through the harbor with all of the information that they possibly could have to keep the movements of the vessel safe. So really just mapping he was mapping the dockyards, and you saw that, but this is mapping the whole harbor and understanding what everything's happening inside the harbor.
Absolutely. Thanks for that, Corey. And again, just to reiterate the couple components there, there's the scene and the venue data that creates the harbor and the context around it, including the assets like the cranes and the jetties here, the berths, the anchorages. And this is all data that we can continue to add fidelity to, because every one of these objects acts as an endpoint. And you can see for the vessels, we're showing those endpoints with live data. And we're adding multiple sources to that data. So to Corey's point about the alerts and the berths, what we're doing is we're taking the real-time location of this vessel, we're cross-referencing it with the berth that it's supposed to be at, and then we're providing a confidence interval based on the color of the vessel to indicate whether it's behaving appropriately. So blue, for example, is we've cross-referenced its location with port control, the external system that is the port information management system here, and we're visually representing it. You can see tugs look like tugs, container ships look like container ships, pilot boats, because what we're doing is we're reducing the number of things that the user needs to keep as a mental model in their head. I'll show you something else interesting from a forensics point of view. Most systems can do a playback, but what I wanted to show you was just a vessel and approach from yesterday morning, because this is how you're able to quickly understand what's happening in the harbor. And this is a good example of some of that logic being applied. You can see how it happened in real time, and we'll play that back at speed. And this has been used for a couple of use cases here in the harbor to understand what may have happened after an incident occurred. So this is happening at pretty quick speed, but you can see the pilot vessel here is coming in with 2 container ships. As we move up north into the harbor here, we're going to see a tugboat that's also preparing to take one of these vessels in. Here's the tug coming up. They're going to meet here at the harbor limit that Corey mentioned. And they're going to make their way to the berths alongside. And what you'll see is, as they arrive in the berth and we check that those vessels have been scheduled to be at that particular location, you'll see the vessel turn a different color, which is indicating that all of the systems are agreeing on what should be happening. You'll see that happen as the tug brings it in. And there's our first one, the Augusta Luna, arriving at berth 27. And then here we have the Tropic Hope that's just coming alongside. And I don't know if it's worth mentioning any past scenarios where you've looked at this, but it's very similar to the use case about Richmond and the permits that are.
Yeah, I mean the history of this is really quite useful. But there's another thing I just want to double back on. Mm-hmm. Is that we talked about the sensors, and we talked about the integration of using a series of different sensors. Things yet to come is the camera systems that we're going to integrate, and our relationship with the Canadian Coast Guard as we move forward is bringing in radar systems as well to increase our confidence on the different types of vessels that are moving throughout the harbor. But these lines, these historical lines, they mean something. And most mariners in this webinar would understand that when an incident happens, we have to be able to rebuild that incident to understand it. And what we're doing with we've had a couple of incidences in the harbor, which, as you do, it's the cost of doing business. We've used data effects to immediately go back to understand what the status is of some of our systems, our vessels that had been interacting with something, and to understand just the situation initially and then create a near miss report that's not detailed, but just enough information to communicate out loud to the stakeholders that need to know. And then later on, we'll go back and we'll collect a lot more data, a lot more evidence. DataFX will be one of those pieces of information to do the forensics, to understand what happened and how do we mitigate it and how do we avoid this from happening in the future.
Absolutely. Thanks for that. So that's just a little demonstration of some historical data and being able to load that and play it back. I'm going to go back to actually the presentation here just to touch a little bit more on the different types of vessel data location data. So AIS is, of course, the foundation, and Corey mentioned the partnership with the Coast Guard in order to get their real-time AIS stream into the application, which serves as the foundation. What we want to do is bring additional visibility into the small vessel movements within the harbor. And what DataFX does, again, is we're unifying different sources of data into a single view. So what we've done is worked with a vendor on computer vision to be able to detect objects and vessels and then stream that information in real time into our application. And we just put the camera up for that real-time stream last week. We've done a number of tests with their ability to detect vessels and measure their course and speed over ground. So the company we've been working with is Deep Vision, and they take an algorithmic approach to doing this computer vision and vessel detection, which is to say that their initial phase is not training a model to recognize vessels. They're doing it based off of their geometry. So it's very lightweight and fast approach to it. But for DataFX, we're able to integrate any potential vendor who's communicating vessel location. But this is just an example of one of the cameras that's gone up in Halifax and some of the testing that we've done. So this is a view from NSCC if you've been here. And this has actually since been focused on the South End container terminal, but you can see two sailboats that they've put the bounding box in to demonstrate how their computer vision is detecting those objects. And then what they're streaming to DataFX is, for those of you who are interested in this, is the JSON stream with the object detection, the course over ground, speed over ground, and the latitude and longitude of the vessel, which is what allows us to plot that in real time into the application. And this is just an example of some of the tests we've done with that historical data. So part of it is the classification. And then where it gets particularly interesting is when we start to think about what the third set of data would be to give the entire picture, which is radar. And we're very much working towards integrating that in real time. And where DataFX's core competency is being able to merge those three different sources of information. And we plot them in the real world, we cross-reference the timestamps, and then we're able to merge them into a single object. And this is just a demonstration here where we take synthetic data that we've generated based on the formats of radar, AIS, and computer vision. And you can see the logic applied in the application as we measure their course over ground, speed over ground. And when they get within a certain correlation, we merge them into a single track. And that's what's going to give the user the ability to have a higher level of confidence on a vessel's location, but also to identify the activity of small vessels where there may only be one source and not as much metadata about them. But that goes to how the game engine is merging those tracks and then representing them. And that's key when we get to some of the logic that we've included in the application. Corey mentioned, and we discussed a little bit about providing alert based on the vessel behavior when it's in the wrong berth or anchorage, based on cross-referencing it with the port information management system. But some of the other alerts that we've worked on, which were alluded to earlier, is providing alert for high air draft vessels, basically cross-referencing the real-time bridge air gap with the tides and the vessel's air draft to provide that alert, as well as predictive collision detection. So that's based on the vessel dimensions, and again, course over ground, speed over ground, and applying a framework, an academic framework, to whether those vessels are likely to collide. And you can see that in practice when tugs are interacting with the container ships. But it's worth reiterating that DataFX's approach here is really to integrate those different alerts into a single place. And if you have a vendor, for example, who's providing an alert, let's say they're detecting an object in a restricted zone and that system generates an alert, we can integrate that into the platform. And the same goes for predictive alerts. So if you are predicting a vessel's arrival time, or there's another interesting project here at the pier, which is predicting any high air draft conflicts for vessels that are transiting the Narrows, we can integrate that into this single interface. And that's, again, a big part of where DataFX fits. It's tying it all together into a single perspective. And I'll share just a few of the lessons learned that we've experienced going through this before I show you where the product development is going. But the biggest thing that I think enabled the successful process here, or project here, was the cooperation or the environment that the pier provided with access to the operations center, where we could test the software and get immediate feedback from the operations center staff. And that's something we continue to do to get that feedback loop, because again, our capabilities to configure it for a particular set of needs.
I just say that the operations staff aren't, just the ordinary folks that would walk off the street. Not that there's anything wrong with that, but they're made up of mariners that were seagoing seafarers that decided that they wanted to hang their hat up for a while, and so the piers got that type of access to professional mariners. Also, former terminal yard bosses that used to operate and function in South America in terminal yards, and also shipping agents. And shipping agents, nobody should ever underestimate the value and the talent of a shipping agent. And all those different talents are in the operations center to provide feedback to this and other systems that are being tested and put to work in the pier.
Absolutely. Getting their feedback has been hugely valuable. And another component here is looking at the data that gets integrated. So there's the agreements with the government of Canada that Port Halifax has in place, which makes verified data available to them through AIS and in the future here at Radar. Those data sharing agreements, I think, are a good model that can be visited for other ports and infrastructure. I know the West Coast is looking at increasing visibility to vessel traffic, and those two things, AIS and Radar, I think, can build that more holistic perspective. And then computer vision, I think, is best served as a way of focusing on areas of particular interest to provide another layer of visibility. It has been interesting kind of scanning the innovation ecosystem across Canada, looking for open source radar data sets. They don't exist. And during the course of the project, we had to go to the German Aerospace Center in order to get some radar data that we could work on integrating into OneHarbour. So that was a bit of I think, a gap in the data available within Canada for research, because I think a number of companies, especially those who are doing some kind of predictive machine learning on various data sets, could benefit from. So that's worth speaking about is with these different groups. Also deploying hardware here, I think the relationships in the port enabled a lot of the hardware to be set up and installed. So there's now 4 cameras in the harbor where the computer vision software will be deployed. There's 2 on NSCC, which is that view I was showing everybody earlier, basically on the east side of the harbor, looking at the Narrows and the container terminal, and then 1 on the Halifax ferry terminal going up, and another at the south end terminal here. So that was enabled, 1, through the relationships that the port has, but also 2, being able to show those stakeholders what's happening in the harbor, and for them to have their own kind of common operating picture and shared situational awareness. And again, here at the pier here, there's a lot of interesting organizations and companies, and what we continue to do is have conversations and set up the infrastructure. So if somebody has an interesting data input, we can make the endpoint for that. Whether those are weather sensors that are better understanding localized wind patterns, or like OceanSync is an example, if anybody's familiar with them, or what Marine Labs is doing with smart buoys. All of these can be things that are integrated into this common operating picture. And where things are going and what we're working on now before I actually go back to the applications for a few minutes before we do the Q&A. So I mentioned earlier at the top of the call that DataFX has done quite a bit of work with the Royal Canadian Navy, and we're in the process of standing up both of these applications this digital dockyard application solution on both coasts after successful testing with the RCN. But we actually had folks from the West Coast and the East Coast down here at the Port Operations Center for Corey to share lessons learned in standing up the situational awareness here at the port. So this just speaks to the dual use case, the dual use technology that we have here, because there's a number of stakeholders in the harbor, and being able to share that information and have a shared understanding for things like emergency response and whatever may need to be coordinated. It's a good opportunity to bring people together, and I think there's the Coast Guard opportunity too. Also to say that some of the capabilities we're developing with the RCN will be well suited for the commercial side of things. So I'm going to go back to our software here and show everybody something interesting from the kind of King's Harbour Master perspective that the Navy's using. So I'll just show you again, pull up another tab in my browser here and load up another virtual environment, which is to say it's very easy to give people access to this so that they can see whatever information they have permissions for. So I'm going to take us over to the West Coast because that's where our hosts are today on Vancouver Island, and I'll load up CFB Esquimalt here. And this is our test environment where we can see the entire naval base, the vessels alongside, activities associated with those vessels. Very similar to what we actually have in Port Halifax. The activities are coming from the port control system in that case. In this case, we've integrated the King's Harbour Masters spreadsheets. That's what they're using right now to track activity. But we've also included a lot higher fidelity information on the jetties. Again, that's because this is the level of information they have, and we can set this up for any end user. Here you can see we're tracking the availability of mechanical services and power services alongside, which helps when you're scheduling and coordinating vessel activity and the work that needs to be done. Using the same framework, we've mapped hazards across the base. We've taken a look at the laydown areas and assigned activities and locations there. Again, all of this can be updated by the user in real time. We can save that information. We can push it to a back-end system that's already managing this. And then you can get into higher fidelity if you wanted to get into the buildings and the other infrastructure. Here we were tracking AEDs and their expiration dates. So it really is about whatever information you have and positioning it into this single view. But what I'll show you here is of particular interest when it comes to scheduling and deconflicting activity. So right here we have HMCS Calgary with a loft activity. So what we've done is we've designated a safety zone for this activity, which has been scheduled. And then what's going to happen when I schedule an activity right beside it is we're going to check whether that activity is safe to happen here. So this is a quick real-time demo. And if we pick a different type of vessel, we'll pick one of our AOPS. We'll set it at the jetty next to that frigate that we just looked at, and we're going to pick a radiate activity because that will conflict with our aloft activity here. Any one of these seem like a large radius? Which one? There we go. Okay, and you can see right out the gate here, I've got a safety warning and collision confirmation because the game engine is essentially checking if there's an overlap in these safety and hazard zones. So I'm going to continue for the sake of the demo, and activity has been created. So if I zoom out, we can see what the safety radius of this RAD-HAZ is. And we can, again, make that more accurate and particularized based off of working with the subject matter experts, but it's very clear that it overlaps with this aloft activity, and the KHM or anybody coordinating this would not be able to do this or execute at this time. So they can deconflict and schedule, but that applies just the same in the commercial harbor with activities like Divers Down.
Yeah, the reason why this is really important is for folks that aren't aware, currently the way this is done to deconflict in the harbor is phone calls. And first thing in the morning, there's a position called the officer of the day. And the officer of the day, each one of the ships that are in harbor will call the King's Harbour Master's office and be in queue for a call. And then to ask about any kind of activities that are scheduled to happen in the harbor. And we all know that schedules change. But that's the level of fidelity that they're operating at right now, where they make a phone call, they write it down on a piece of paper, and they brief their ship's companies on the activities in the harbor. But as the day progresses, we all know that scheduling maintenance activities have to change for a whole host of different reasons. People don't show up for work, or there's a new priority that you have to, you can't go aloft, you have to radiate to do some certain things. And having a system like this at your fingertips, you could quite literally shut off an activity and turn on another activity. And the people that are out in the field that are working the ships will get an alert on their tablet that say that they can't do that activity any longer, and understand why, and then go back to their shop, or just make a simple phone call and understand why they can't do that. So a far more sophisticated way of doing business in the dockyard, and really easier to avoid the mistakes of safety errors where people are radiating people and things like that. And you would be surprised to see how often these radiation incidences occur in a year.
Absolutely. So with 10 minutes left, there's more that we could show in terms of specific features here, but I think that gives a high-level overview of the project that we've done with Port Halifax and the work that we continue to do with them, and where the product's going in terms of providing situational awareness, both at the port here with the civilian Harbour Master, and also at the Navy with the King's Harbour Master. So thank you, everybody.
Thanks so much, Corey. And Corey, that was a great presentation, and love the displays and interactiveness of it, where you can really see it in operation. So we've got a couple of questions in our chat. I'm just going to start us off with. So you mentioned, I think when you were starting off, that the overall idea was to improve supply chain efficiency, but it's pretty evident that there's a lot of safety benefit as well. Were you surprised by any other benefits that kind of came out of this system that you maybe hadn't anticipated when you were first getting started?
Well, the first surprise for me was that as soon as we turned it on, that it was doing all the things that we said it would. I don't know how many times you've been involved in procurement, but I've got a long list of opportunities where I can reflect on things that were being introduced or deployed that really didn't take off initially, and there was a lot of work going on in the back end to try to get it to work. And this thing worked immediately. There's a lot more work to be done, and I'm just really excited about this particular project because it brings a whole host of other projects, and kind of really exploits all these different pieces of technology to give everybody an opportunity to really demonstrate what they can do, but in one single window. So pretty fascinating stuff, and I really see opportunity here where when we talk about efficiencies and we start talking about transshipment between Halifax and Montreal and things like that, as vessels are preparing to go or delayed, as they're delayed inside our harbor, you can appreciate if another port has this system, they have insight into our port to see that vessel hasn't left yet, and so they will resource their activities around the fact that that berth isn't going to be used just yet, or that vessel's left early. We got to hurry up and clear that berth so we can keep the supply chain activities going. So there's real opportunity here, both from a Canadian sense across the country, but also globally with our sister ports that we do business with.
And those are huge advantages. There's a question in the chat about what do you do in a case where a vessel turns off their AIS, or maybe doesn't even have AIS because it's a smaller vessel. And
that's go ahead. Yeah, so that's really it, right? I mean, that's the whole point of getting all these different sensors integrated and data fused together. AIS right now is a bit of a crutch, and that's one of the things that I brought to the pier to say that's the only thing I've got. So if they turn off their AIS, then I got the Mark 1 eyeball. Oddly enough, my operations center is actually on the opposite side of a building, not looking at the water. So that's really challenging for me to see, right, for my team to see. So when they integrate cameras and they integrate radar and things like that, AIS is just one of the many different pieces of information that we have that will be at our disposal in the future. And don't forget, of course, if a vessel turns off its AIS, it's probably under escort with a tug or in vicinity of a pilot boat. So there are other ways for us to communicate with that vessel to get it turn its AIS back on pretty rapidly. Also, while we don't have visibility on it yet, our vessel traffic management system in the Port of Halifax are responsible for clearing vessels to enter the harbor and to make sure that they're on the schedules to come into the harbor, and they have access to all these sensors at the moment. The operations center just doesn't.
Robert Booth has a bit of a follow-up question on AIS. Has this platform provided you with any examples of AIS jamming or spoofing that could be documented?
So that's a great question, because I think it helps with the distinction between what DataFX is really doing. Like there's a number of companies out there who are detecting dark vessels by doing the data science analysis of AIS. But that's not what DataFX is doing. DataFX is taking AIS as one feed that's representing where a vessel is in the real world, and we're cross-referencing that with other information to show the end user all of the information they have available in this single spot. So if a company was doing the computation that's required to detect a vessel spoofing, and they needed to push that alert to the end user, the operator, who is otherwise maintaining situational awareness, this is the interface that can integrate and present that information, saying this is what you need to look at right now. And hopefully that helps. I'm happy to unpack that a little bit more if anybody's interested.
On the topic of all of these multiple streams of data, kind of got sort of two directions that I would want to go with that. But one is, have you encountered any, or rather, how do you manage your data quality to make sure that when you're bringing all of these different streams of data together into one platform, that errors aren't getting introduced or, transposed, or things happening that are, because they're from so many different types of information? How do you handle that?
Good question, and it really depends on like the data quality of the data stream up, like the data upstream, and then it's on a case-by-case basis. So the GIS information that we have is very different from the vessel location data that we have. When it comes to vessel location data, that's really about the logic behind correlating those different positions and the timestamps associated with them. So there's a rigorous approach there. And in terms of the GIS and let's say the quality of those inputs, it really is about the source. So what DataFX is good at is rendering that information in whatever quality or state that it's in, and creating the foundation so you can add fidelity. And at least it provides a place, and this is actually a great example for people to QA their own data. Back with GE Transportation, one of the big examples was when we were the front end of their terminal operating system, and working with all the people on the calls there, the different stakeholders, we would show many containers stacked in the same location. And they would ask us, is this your front end? And then we're saying, no, this is the input we're getting. Some cache hasn't been cleared, and your system right now is pushing information thinking, dozens of containers are in the same spot. So it provides visibility as the foundation.
So the other part to that is the operator in the operations center. The operator in the operations center works in a 24-hour clock that's very specific times in the day. The operator is doing some very specific things to look at sensors to make sure that they're still operating, and that's the safety component of our marine safety management system. The other portion of that is our port management information system. As at the front end of this briefing, you would appreciate that it was very mechanical and operator interactive. So if there's a request for diving, there's a request for hot work, or there's a request for an alongside position, the operator still has to approve all those things. So there's an interaction, an interaction or interface between the human and the machine still.
Okay, thank you. Nicole has a great question that do you see this application working in a much smaller harbor or port system than what the Port of Halifax is? Um, what would you see as the benefits of the smaller scale operation?
Yeah, absolutely. When it comes to any scale of operation, what DataFX does is provide more value to the data that you already have. So in a small scale operation, the starting point would be what's open source and available. There's open source GIS that could be the starting point for visualizing it, and open source AIS. And that there would provide you with more visibility than you would have otherwise. Out of the box, like our capabilities of the platform allow users to add information. We didn't really go down that path of talking about how people can add essentially tags, if you will, that can represent activities like navigation warnings, or they could represent incidents that have happened. So all those capabilities are available to a smaller port, and how they use them is really up to them as a basis.
I would just add that marine safety, small port, large ports, it's all very important. And for a smaller port, if you don't have personnel powers of 24/7 operations, you do have the capacity to have this information available to you on portable devices. So if you're a smaller port, you go home at 5 o'clock at night, you still have visibility on all the activities and live visibility on all the activities, provided you have the inputs for them.
Amazing. Well, I could go on asking questions all day, and I think that others could as well, but we are at the end of our time. So thank you so much for your presentation today. It's been really helpful. And the question we didn't get to in the chat, maybe I can ask you, Corey, to address that, and I can get in touch with the person afterwards.
Yeah, it's a really good one, and I'll do it super briefly here. But
Okay.
essentially, the tech stack is proprietary in that we've used open source components to configure them, but all of the protocols, we use APIs, the data is in an open source or open protocol format. So once you use this data, you can use it for whatever platform. We're making it very accessible here. So easy to get started.
Fantastic. Well, thank you everyone for your participation today and attending this session. I really appreciate Corey for your knowledge that you shared with us. And the recording and slides will be posted on the Canadian Marine Shipping Risk Forum webpage. And I'll send out the links to everyone who registered so that you can get access to it, rewatch any parts that you wanted to revisit. And I hope you'll sign up for the next session in this webinar series. We'll be focusing on underwater noise mitigation in January 20th, 2026. And I'll send out a link to register when I send out the recording of this webinar. Thank you everyone for your participation today. Have a great rest of the day.